The grand finale, from cosmic spark to eternal darkness. Imagine the universe in its infancy, an unimaginable explosion of energy, a burst of light, and the birth of everything we know. Now, fast forward to the very end. Instead of a fiery inferno, picture the opposite, a slow, chilling fade into eternal darkness. This is the predicted fate of our universe, the heat death. The universe, as we understand it, is not eternal. It had a beginning and it will have an end. While the Big Bang, the event that brought our universe into existence, was a moment of unimaginable energy and creation, the universe's eventual demise will be a gradual descent into stillness and cold. This stark contrast between the universe's vibrant beginnings and its predicted quiet end highlights the profound nature of time and entropy. Just as we are born, age, and eventually pass away, so too will the universe undergo its own life cycle, culminating in a state of maximum entropy and minimum energy. Understanding this inevitable end, while daunting, allows us to appreciate the preciousness of the universe's current state, a state teeming with stars, galaxies, and the potential for life. The unstoppable tide heat death and the fate of energy. The concept of heat death is rooted in the second law of thermodynamics. This law states that entropy, a measure of disorder or randomness, always increases in a closed system. Think about a messy room. It takes energy to organize it, but disorder naturally increases over time. The universe is also subject to this law. Stars, the cosmic furnaces that light our night sky, are constantly burning through their fuel. As they do, they release energy and increase the entropy of the universe. Eventually, even stars die, leaving behind remnants like white dwarfs, neutron stars, and black holes. Over incredibly long timescales, all available energy will be evenly distributed throughout the universe. There will be no more fuel for stars to burn, no more heat to drive chemical reactions, just a uniform, cold and lifeless expanse. This is the essence of heat death. It's important to remember that this process is gradual and occurs over unimaginable stretches of time. The universe is still in its stelliferous era, a period of star formation and activity. However, the seeds of heat death are already sown, and the universe is slowly but surely winding down. A universe in decline, from star births to black hole domination. The journey to heat death is a long and drawn-out affair, marked by several distinct stages. Currently, the universe is a vibrant tapestry of galaxies, stars, and planets. New stars are born from collapsing clouds of gas and dust, continuing the cycle of stellar evolution. However, as we look further into the future, the rate of star formation will slow down. The raw materials needed to create stars will become increasingly scarce, and galaxies will gradually dim as their stellar populations dwindle. This era, known as the degenerate era, will be dominated by the remnants of dead stars, white dwarfs, neutron stars, and black holes. As time marches on, even these stellar remnants will eventually decay. Black holes, once thought to be eternal, will slowly evaporate through a process called Hawking radiation. This process, while incredibly slow, will eventually lead to the complete evaporation of even the most massive black holes. The universe will then enter its final stage, the black hole era. In this era, black holes will be the dominant form of matter, but even they will eventually succumb to Hawking radiation, leaving behind a universe populated only by a faint and ever-cooling sea of photons and other fundamental particles. Against the dying light, can we outsmart the universe's end? The prospect of heat death is a sobering thought. Is there any way for life, or at least information, to survive the universe's ultimate demise? While the answer is far from certain, some theoretical possibilities offer a glimmer of hope. One idea involves harnessing the energy of black holes. As black holes evaporate, they release enormous amounts of energy. A sufficiently advanced civilization might be able to capture this energy and use it to power their civilization, effectively delaying the inevitable. Another possibility lies in the realm of digital consciousness. If we can transfer our consciousness into a digital form, we might be able to exist independently of our physical bodies. This digital consciousness could potentially survive in the cold, empty universe long after biological life has ceased to exist. Perhaps the most audacious idea involves escaping our universe altogether. Some cosmological models suggest that our universe might be just one of many universes in a vast multiverse. If we could find a way to travel between universes, we might be able to escape the heat death of our own universe and find a new home in a younger, more energetic universe. The unthinkable possibility, acceptance, and the void. While these possibilities offer a glimmer of hope, it's important to acknowledge the very real possibility that survival might be impossible. The laws of physics, as we currently understand them, paint a bleak picture of the universe's ultimate fate. Entropy, the relentless force driving the universe towards heat death, appears to be an insurmountable obstacle. Even if we can delay the inevitable, the universe will eventually reach a state of maximum entropy where no further work can be done and no life can exist. This realization, while daunting, can also be strangely liberating. It forces us to confront the true nature of our existence and appreciate the preciousness of the present moment. In the face of cosmic insignificance, our lives take on a new meaning. We are fortunate to exist in this era of the universe, a time of stars, galaxies, and the potential for life. Instead of fearing the end, we should embrace the present and strive to understand and appreciate the universe in all its complexity and wonder. Our cosmic duty, embracing the present, preparing for the future. The heat death of the universe is not an immediate threat, but it is a stark reminder of our place in the grand scheme of things. We are but a blip on the cosmic timescale, inhabiting a universe that is both awe-inspiring and indifferent to our fate. This realization should not fill us with despair, but with a sense of purpose. We have been given the gift of life in this extraordinary universe, and it is our duty to make the most of it. We should strive to understand the universe, to appreciate its beauty, and to leave behind a legacy that will outlive us. While we may not be able to outrun the ultimate fate of the universe, we can choose how we face it. We can choose to live our lives with purpose and meaning, to appreciate the present moment, and to leave the universe a little better than we found it. This, in itself, is a victory against the dying light.